Hey guys, what's up? So we're going to be doing a synthesis based on the stuff you guys learned in exam 3. This one is going to be using protecting groups, so we're going to be able to discuss uh, how to use protecting groups. Remember, so in the previous video on synthesis, with protecting groups, we mentioned the three cases where you got to be careful and when you should be using maybe a protecting group. So now we're going to go through this, all right? And it's going to be using a bunch of things that you guys have learned for your exam 3. Okay? So let's get started. So they're asking us to synthesize this compound from 4 carbons or less. Okay? And I'm sorry if there's any background noise. So let's get started. So what do you see here first? We see an alcohol right over here. Tertiary alcohol. Alright? And we have this carboxylic acid. So what's the first step we're going to do? Well, there's actually a couple ways we can do these synthesis, and you'll see that the more stuff you guys learn, the more ways there will be to do these synthesis. Alright? So the first step going backwards, you see that we have a carboxylic acid. The only way that you guys know how to make a carboxylic acid is through Jones. So you could just write Jones, and we would end up drawing it like this. Now, as always, when you go back a step, let's go forward to see if this is going to work. Here we now have a primary alcohol, and we know primary alcohols with Jones become carboxylic acids. This tertiary alcohol, to remember, tertiary alcohols do not react with Jones or PCC. So this is a safe thing to do. Alright? If I go Jones, this tertiary alcohol will not be reacting. Okay? So our first step was good. Now, what's the next step? You have 2 alcohols on your compound. Usually when you have something like this, you're going to have a protecting group. Now remember, since we're going backwards, we have to act as if we're sort of taking off the protecting group. To do that, we write TBAF. Okay? And so now you can pick whichever one you want. Whichever alcohol you want, alright? I'm just going to pick the one on the right. So we're going to write OTMS. Remember the structure of it if you're wondering, which you should know is going to look like this. Okay? And then obviously connected to the O or the other is the rest of the carbon chain. So we have this. Now we can cut. Now, actually, even before I cut, you may be wondering why I picked to protect this one, right? Remember, you always want to make your synthesis as easy as possible. So, if I protected this one, now I'm going to have to cut this time, and again here, or something like that. Whereas with this OH, I can cut something like here and knock out a bunch of carbons at once. Okay? So that's why I protected the one on the right. So, remember, the cut, you look at the carbon the OH is connected to, and cut the bond right that it's connected to. So, this one. Right? Sure, we could cut this one, but that's not going to really help us much. So I'm going to cut right here. So let's see. We put the lithium here. And then our step 1, remember we have, look at the red carbon. That's going to get our carbonyl, and it's going to have methyl and an ethyl on it. So we're going to write that's your little carbonyl piece, and then just H2O. Okay? Remember, they specified 4 carbons or less, so also this must be 4 carbons or less. Okay? Now, we have a lithium, so using your toolbox, you want to write Li to get a Br there. Okay? And so now, how many carbons do we have? 1, 2, 3, 4. Alright, we're at 4 carbons. We're done. We don't need to do another cut. But we still have this protecting group on, so we got to take it off. To do that, we do TMSCl over ET3N. And we just take it off. You get that? Okay? And so that's how you would have done it. Now, there is one other way to do the synthesis. Or at least maybe it's not that obvious of a way, but it also could have been done. And so this could have been done without a protecting group. Still would have had to use Jones. Oh, here we go. Still would have used Jones. Now, what you could have done is we could have done a hydroboration. Remember, these are alkene reactions. You should always know them. All right, even in Orgo 2, I use these. So here we have the double bond. Remember, that's how hydroboration works. We put the double bond here because hydroboration adds alcohols to the least substituted carbon. So now what we can do, we don't need to worry about the other OH. Now again, we're going to have this cut. Right? And then our answer is just going to look like this now. Okay? And so that's another way to do that synthesis. Now, let's go on and try another one. This one isn't going to be using, oh, no, never mind. We are going to be using protecting groups for this one. Now, don't get freaked out by the double bonds, all right? Again, it's going to use a lot of the things you know, okay? And this one also has multiple ways of doing it. So, we only have one alcohol here, so we can go right into the cutting. So, it's going to probably be easiest to cut right here. Well, actually, maybe not easiest, but I'm just going to be cutting it there. Okay? And so, look at this double bond piece. We have an Li. I'm going to have that. That is also possible. You can have the lithium coming off of the carbon of a double bond. No rules against that. We're going to get this. So now you have a carbonyl. You know what to do. It's a secondary. It's on a secondary carbon. So we could do PCC or Jones. They'll both give us the same exact thing. So I'm going to just use PCC because in the previous example we used Jones. So let's just practice other reagents. All right, so now we have this. So what are we going to do? So we remember we could just keep cutting at this point, right? We actually don't even need to worry about protecting groups. That was my mistake. You can put a protecting group if you want to focus and try to do something with this double bond, okay? But that's just going to make this excessively harder on yourself, all right? We don't want to make that into like an alcohol or anything. So just keep cutting. So I'm going to cut right there. Remember, this is a methyl coming off, and here's the hydrogen. So our piece over here is going to look like this. Cut again. Oh, not yet, not cutting. Li. The Br. Right? Now, here's another thing you guys learned for exam 3. Now, when you have a primary Br, and going backwards, you want to turn it into an alcohol, we need to put PBr3. All right? If you put HBr, right? So remember, we have alcohol. It's going to be alcohols going backwards. Right? So think of it if I put HBr. It's going to protonate this alcohol, giving you a positive charge. Right? Then we can always have the possibility of shifting. So which is why we always try to put PBr3. Right? For primary and secondary, you want to put PBr3. For tertiary, you want to put HBr because PBr3 goes through an SN2 mechanism, and in tertiary, it won't. All right? So put this here. Oh, and actually, based on the mechanism, if you did use HBr, For primary, you wouldn't really shift, but if you had a secondary alcohol, you might as well. You could have. Alright, so here's our OH. Now again, cut. I'm just going to cut right there. That's the only place you can cut. Right, and we have two hydrogens as our substituent. So we do this. Put the Li. 1, 2, 3, 4, 5. Right, so we have 5 carbons right now. So we got to cut this one down. So how exactly we're going to do that again? So let's Li. Put the Br. Right. Again, we're going to want to put PBr3. Turn it into an OH. Now again, cut. Step 1 is going to be, again, these. We put the Li right there. Okay? And yes, you can have the lithium coming off of the carbon of the double bond. That's perfectly fine. Okay? And that's how you would have done that synthesis. A little bit longer, right? So you're going to take a little bit more steps to do that, but there is a shorter way. And you guys may have seen this already. A lot of TAs like to show this method, and it can be very useful. So what we can do is we can, again cut. Let's just cut from here this time to save us some time. We could have done that originally. So that's going to look like this. Alright, we're going to cut right through this bond. OH becomes a carbonyl, and the substituents it has are a methyl. And there's 2 carbon group with this double bond. So that's what we put there. We have this lithium. And so now we're going to go again backwards. PBr3. Oh, shoot. Sorry. Li. Br, and now we want to do PBr3. So we have the OH here, right? This is called an epoxide cut. We can, all the cuts cut 1 carbon at a time on your main chain. This can cut 2. The way that we do this, let me redraw this a little bit different, a little bit cleaner so that it's easier for you guys to see. What you do is draw a dot. You can go to this carbon. This is your alpha carbon. There's your beta. All you do is draw a dashed line to the carbon, the beta carbon. Now you can see that's how your epoxide is going to look, right? You see this triangle forming. So you write what that epoxide looks like. So in this case, there are no substituents on the alpha carbon. So we're going to, or the beta carbon. And so we're going to just draw this. Step 2 is still the same H2O. Oh, and I forgot the double bond. And so we're cutting now this way. So you want to make sure you have the substituents that are on the beta and alpha carbon on your epoxide. So that's how that's going to look. Okay? Now, if you're not comfortable with the epoxide cut, because it can get a little bit tricky, especially to follow the rules of Boat, then don't bother, alright? You guys know how to do the regular cuts. Yeah, sure, it'll take you a little bit longer, but you won't lose any more points for that, right? Whereas, if you mess up on the epoxide cut, you could mess up multiple steps, alright? So, whatever makes you guys comfortable, follow it that way, okay? I hope this little synthesis video helped you guys get a little bit more comfortable with exam 3 style synthesis, and I will see you guys in the next video. Good luck in your exam.